I am back on page 13 for one more term, and then we have one to put on page 14. But this one is volume. And volume is marked with the capital V, and it's defined as the number of cubic units needed to fill a space, let's say a three-dimensional shape, three-dimensional space, to capacity. So let's take a look at this cube I've drawn here. This is a three-dimensional shape. And suppose I tell you that this cube is 5 inches by 5 inches by 5 inches. And I want to know how many cubes it would take to fill this space, to fill it to capacity. Like you would fill a fish tank with water, or a block with cement, or a duct with air. How much air would it take to fill this cube? That's a volume formula. And if you're dealing with a cube, your formula is edged to the third power. So you would say 5 to the third power, or 5 times 5 times 5 is 125 cubic units. In this case, the unit is inches. So it would take 125 inch cubes to fill this space to capacity. And you could stack those cubes perfectly into that space. It's a very organized filling of the space. We're not just throwing them in there. We're stacking them in there in order so that we fill the space to capacity. Okay, on page 14, we have a word that you may not know, but I bet you've seen the shapes. Composite. It is a shape that is composed, thus composite, composed of two or more smaller shapes. For example, let's suppose that this is the wall of a house. Okay? And that this is the roof that sits on it. That's a composite because you have this shape that you can work with a formula for a triangle, and you have that stuck to this shape. If you have a problem with this kind of image, do you think you would be adding or subtracting to find the area? This one is most always an addition problem. You would find the roof, the wall, and then add those together. There is another kind of composite, and let me try to resize this. I don't know that that's going to let me do that, possibly, here we go. I want to show you this one because this is a very common one. What if you have a square maybe this is a piece of ductwork, and through it you are running a circular pipe. That's not a circle, is it? Try one more time. Okay, so you've got this circular pipe that's running through that ductwork. So this is more like something took a bite out of the circle or the square. So here's the whole square. Maybe this is a block of concrete and we're running a drain pipe through it or a piece of conduit through there. So there's the whole block. And then there is this space for the conduit or the piece of pipe that has to run through there. In this case, would you be adding or subtracting if you wanted to find the area of the blue part? So if I am coming in here and cutting away this part, what am I doing? Am I adding or am I subtracting? In this case, we're subtracting most always. Now, depending on the way the question's worded, but this will always look at this like a bite's gone out of it. So this would be a problem where you would have to find the area of the block and in the area of the circle and find the difference between those two. So with composites, you're going to have to either add or subtract in most cases.